right, here are some examples on how to work with the intermediate value theorem. First of all, you will need to justify your answers when you're using the intermediate value theorem. And so don't forget, when we justify theorems, don't wreck your grade. You always need to show the requirements, talk about the requirements, the evidence, which is actually just the math, and then the conclusion. So always think there are 3 things you need to include. And with the conclusion, you can literally rewrite the question, no creative writing required. All right, so let's look at this problem. Here's a function, and it's asking you, is there an x value on -5 to 5 at which g of x equals 1? Explain your reasoning. If yes, find the value. So the first thing we're going to look at is the very first requirement of the IVT. And the very first requirement is the function continuous. So number 1, so is g of x continuous on -5, 5? If you notice, a function is not continuous when the denominator equals 0. It'll be undefined there, and that will either give us a whole or an asymptote. So right now, it is not continuous. X plus 3 equals 0. So at x equals -3, the function g of x is not continuous. And since x equals -3 is between -5 and 5, then that means that you cannot use the IVT. So there may be an x value, but there's not guaranteed an x value because there's a hole in this function. So in this case, you cannot use the IVT. So on this question, the IVT does not apply. So you can put no, the IVT does not apply on -5, 5. So an x value is not guaranteed. At which g of x equals 1. And there may be 1, but it's not guaranteed. And they're saying, is there a value for sure? And there could be, but we can't say for sure because it's not continuous. So let's look at a different problem. And on this problem, it's asking, the above table shows selected values of a continuous function between 0 and 13 on this interval. What is the fewest possible number of times that f of x equals 4? So we're looking at f of x, those are the y values, and we want to see they're equal to 4. First of all, if I want, I can just look at the table. Since it's a continuous function, the IVT is going to apply. So we're looking at 3 to 4.5. So right in here, from 3 to 4.5, the number 4 is going to be present. If you go from 4.5 back down to 3, the number 4 is going to be present. From 3 to 2.5, 4 is not going to be present. But between 2.5 and 4.4, 4 is going to be present here. So it's 3 times. If you're a little confused and not really sure, if the problem's a little more complicated, you could always draw a graph and label it. My x's are 0, 4, 6, 8, and 13. And my f of x is going to be 3. This is 2.5 is the lowest one, 2.5, 3, drawing not to scale. We're looking for the number 4, 4.4, and 4.5. Here are the values. So let's go ahead and label those points. 0, 3, 4, 4.5, 3, 6, I'm sorry, 6, 3, 8, 2.5, and 13, 4.4, which is about here. Now, it's a continuous function. We don't know what the function looks like. It could be doing anything crazy in there, but we're looking for the fewest values, so we're just going to kind of draw like a line through them, because we know it's continuous, so our pencil should not lift off the page. And we're looking for the magic 4. So let's see. If we draw across, we can see how many times 4 hits. So it's 1, 2, 3. So again, you don't have to draw a graph. You can just look at it. This is usually a multiple choice question, but just in case you wanted to, if you were confused or if it was a complicated question, you could draw a graph. All right, last but not least, we're actually going to show the full proof here of the justification or the reason for our answer. So that when it says reason or justification, you have to justify. So let's read this question. Take a minute to read it. Steve runs back and forth, and we're trying to see if Steve's velocity, so velocity is here, is negative 10 meters per minute at some point t within this range. So we're really only looking at this range right here. And we're trying to see if v of t equals negative 10. So don't forget that IVT is talking about y values. Although it won't be considered in your grade, it's sometimes helpful to sketch a quick graph just to get a visual of what's happening. So this is the t-axis, this is the v of t axis, and our ordered pairs are 4, 30. So let's say 4 is here and 30 is way up here. That's 1 point. And the other ordered pair is 5, negative 15, which is going to be down here. And so here's the two pairs. And it's a continuous function again, so we don't know exactly what it does, but we're like, we're going to kind of just draw a straight line because we're looking for at least 1. And then our value that we're trying to find, our y value on v of t is negative 10, which is going to be maybe here. So, oh, look, there you go. So as you can see, there is going to be some c value here, which remember c is in the middle. It's going to be, or t actually, it's going to be a t value, or on the x-axis right here. There's going to be some t, we don't know what it is because we just have a table here. Some t where the velocity is negative 10. So that means Steve is going to be going negative 10 meters per minute at some point. So to justify or give a reason for your answer, it's time to REC. So number 1, and most important, because if this condition is not in here, you cannot go further. And that is the function IVT, first, is it continuous on AB? That's the first, that's your R, that's your requirement. So let's look at here, it says it is a continuous function. It says it in the problem. So yes, V of t is continuous on 4 to 5. That's the first thing. Number 2 is our evidence. So what we're looking at is we're looking at this point, and we can see that those y values. So if you look here, f of a, this is a y value, this is a y value, and this is a y value. But just to show your y values, what I like to do is I like to go, so first of all you had v of, and we're just going to go backwards so we can use less than, it doesn't really matter. V of 5 equals negative 15, and that is less than negative 10, which is less than 30. And 30 was what value? It was f of 4. I'm sorry, not f, v of 4. So if you notice, right here are the y values. But we just went ahead and did the equals so we can say, okay, this is how we know what they are. We just wrote it down. And this is the second step, or your evidence. So this proves that negative 10, which you were looking for, is in between the values for 4 and 5 of velocity. Third step, and most important, is you need to state your conclusion. By the IVT, and then we're just going to restate the question. So by the IVT, Steve's velocity, so here's the question, we're just going to start right here. Steve's velocity is negative 10 meters per minute, and you can shorthand that if you want, at some time t with, it should probably be within, for less than t, less than 5. So if you notice, I rewrote this entire piece right here because I want to be sure I include the noun, what we're talking about with the units, and the time. So that included all of my thing, my noun, my units, and my time. So that makes sure we're all covered up, and this is how you would justify an IVT question. Have a great night.